Okay, so this is the third question you sent me for your integration. It's the integration with limits 8 and 2 of the natural log of x over x times the natural log of x plus 1 dx. Here I'm going to use a combination of substitution first, but later on I'm going to have to play around with the fractions and finish with a second substitution. It's quite tricky, but I'll explain the trickiest step. The first thing anyway is I'm going to let u equals the log of x. So when I differentiate that, the differential of log is 1 over x. So du equals 1 over x dx. Okay, now we'll notice here that I've got basically the x underneath the line, which corresponds to that x there, and I've got my dx there. So all of that can be swapped out for du. So I've got 8, 2. Now on top, I've got u, which is the natural log of x, over natural log of x, which is u plus 1, and I've gotten rid of the two things I've highlighted in blue, and I can just call those du. Okay. The next step here with this is quite tricky. U over u plus 1, there's no easy integral. It's quite difficult. So the following you're probably going to have to think about a couple of times, and I'll start it off with a very, very simple example. If I had the following, if let's say I had 1 plus 3 over x, and I wanted to add those, well, 1 isn't over anything, so we can make a fraction by putting anything over 1. So first thing we need is our common denominator, which is obviously x. So then I need to multiply this 1 by x. The 3 is already over x, so that's okay. So that can be written as x plus 3 over x. Now what we have here is the reverse of that. We have a fraction, and it would make our lives easier if we could turn it back into something like this. So kind of how would you think about that? Well, ideally, if you could have it as a 1, that would be perfect. I basically need to end up with an x plus 3 on the top. So when I have the entire top line over x, it means each individual thing is over x. And of course, x over x, anything over itself, is 1. So I can turn it into quite a nice fraction. Now let's just do one more example of that. Let's say, or no, should we just use what we have here? Here, so I have u over u plus 1. Okay, now the reversal of this one, though, is quite tricky. If I try just to reverse that, I've only got one thing on top, so it's just u over u plus 1. There's no way for me to get the second fraction, so I have only one thing on top. So I have to kind of invent it, all right? So what could I rewrite that as? Well, I can only have u on top, so it's not as if I could write u plus 1 on top. But if I did u plus 1 minus 1 on top, well, these are the same now, because a plus 1 and a minus 1 is 0. So I'm just left with u over u plus 1. So if I write it as u plus 1 minus 1 all over u plus 1, it's the exact same fraction. Now, as I said, everything, we can take the individual pieces and put them over u plus 1. So here I have a u plus 1, and that's divided by u plus 1. And then I have minus 1, and that's divided by u plus 1. Now we see in this case, anything over itself is 1. And then I've got minus 1 over u plus 1. So that's how we'll rewrite our integral. We can write it as the integral from 8 to 2 of 1 minus 1 over u plus 1. So take time to have a look back at that. It's quite tricky. Now, the first thing will be pretty easy to integrate. Okay, so we're going to do an integral of 1. That's easy. But then we also have to integrate 1 over u plus 1. And that's a trickier integral where we're probably going to have to do another substitution there. So obviously when we integrate the 1 with respect to our du, it's just going to give us a u. That's no problem. But what's this chap going to become? Well, if I let u, or no, sorry, I've already used u, apologies. So I'm going to have to use something else instead of u. Let s equals u plus 1. Then ds du is just equal to 1. So ds is equal to du. So let's see how that affects us. We're integrating all this with respect to du. So I'm integrating the 1 with respect to du and the 1 over u plus 1 with respect to du. Okay, you're integrating every part basically as normal. But what I have here now is I'm able to now write this in terms of an s, and here I can swap out a ds for a du. It's saying they're the same thing. So I've integrated my first part, he's fine, minus now the integral of the following. So instead of 1 over u plus 1, it's 1 over s, and I now know I can write du as ds if I want. Right, we keep rocking away at that. So I've got the first part integrated. Now, s to the power, what's the integral basically of 1 over s? Okay, the integral of 1 over s. So we're looking at our formula book. The integral of 1 over x is the natural log. So we're going to say log of s. Perfect. So we're nearly there. So we've got the vast majority of it done. All we need to do now is make sure we're going to put our limits in at the end, which are 8 and our 2. But before we can do that, we have to sub back in for u and s as well. So what did we say u was at the start? We said u was log of x. Grand job. Log of x, no problem. Minus now the log of s. What the hell was s? Well, s is u plus 1. So it's minus the log of u plus 1. I'll just throw it in brackets. We won't need the absolute value. Or will we? No, we won't need it in this case. U plus 1. Now I still got the u there. And remember, my u is the log of x. So here we go. The log of x minus the log, and u we said is x. Sorry, apologies. 2 seconds there now. I made a mistake there, didn't I? U is the log of x, so when I put what goes in for u, log of x goes in for u, and then plus 1. That's lovely. Okay, so that's our integral done. If we didn't have limits now, we'd throw in a plus c, but we do have limits. Our limits are 8 and 2. 8 and 2. Okay, so now we need to start subbing in for our x. So the first thing I'm going to sub, I'll tell you what, I'll sub in rather than let the video run too long. I'm going to sub in. Right, input the both of those, so 0.95469 and change for the first one, 0.166558 and change for the next one. Actually, yeah, no, that's fine. Okay, and 1 minus the other gives me 0.78813185336 and on and on and on, however many decimal places you're looking for. Look, as always, just double check, quickly run over my expressions in case I made a stupid mistake like leaving out a minus here or there, but I'm quite confident in that. Okay, thank you.